traits of the crop, weather conditions, soil type, its nutrient status, management practices, and other inputs available. And among these, weather and soil factors play a very important role, particularly more so in Indian condition, where these erratic weather such as droughts and floods are imperative rather than being exception. So efficient cropping system therefore required a proper understanding of these agroclimatic conditions and variations from different regions. And hence our entire nation or entire country was basically divided by the government of India in its 7th Planning Commission broadly into 15 agroclimatic zones. And here, please mark it, I'm talking about agroclimatic zones and not agroecological regions. So those 15 agroclimatic zones, as you can see in this legend provided over here, let me change it so that you people can see it in a much better way. See, these agroclimatic zones are these 15 regions that our country has been divided into. And we'll have a quick tour of these 15 regions. And it is very easy if you are with me and you're listening to me. Look, as FAO defined this in 1983, that agroclimatic zone is what? It's basically a land unit, right? It's basically a land unit which is represented accurately or precisely in terms of two major categories. And those two broad major categories were climate and the length of growing period, right? On these two broad criterias, our entire nation was divided into 15 regions or 15 zones, which were called as agroclimatic zones. And those 15 zones were in such a manner that I'm going to show you. Look, here we have the first zone, which is the Western Himalayas. Over this side, we have Eastern Himalayas. Again, we have Western Himalayas over here and Eastern Himalayas over here. Then what we have is the Lower Gangetic Plain, the Middle Gangetic Plain, Upper Gangetic Plain, and Trans-Gangetic Plain. Okay. Let me repeat that once again. We have Western Himalayas here and we have Eastern Himalayas here. The Lower Gangetic Plain, Middle Gangetic Plain, Upper and Trans-Gangetic Plain. It's very easy. Now what follows is these 4 different regions, which are the Central Plateauan Hills, the Eastern Plateauan Hills, the Western Plateauan Hills, and the Southern Plateauan Hills. So basically it's not so difficult as it seemed to be. See, we have the Central, the Eastern, the Western, and the Southern Plateauan Hills. Then we are left out with these 2 regions, which are the coastal plains, isn't it? So this is the Eastern Coastal Plain and this is the Western Coastal Plain. And then we have the Gujarat Plains, the Western Dry Region, and the islands. So that's what makes up our 15 agroclimatic zones, right? So, as I stated earlier, our topic is not about agroclimatic zones, but agro-ecological regions. And people often confuse between these 2 terms, agroclimatic and agroecological regions. And it is a genuine confusion, I would say, but there is a subtle difference between these 2 terms, agroclimatic zones and agroecological region. Let me put it in a layman perspective. Now, this agroecological region, abbreviated as AER, right, agroecological regions, is basically an improvement over agroclimatic zones, right? Now, what do I mean by an improvement? See, these agroecological regions are also land units. That means our entire country has been again divided into a number of regions, but these land units have been actually carved out of these agroclimatic zones, these 15 zones that we talked about just now. And then those have been superimposed on landforms and soil conditions. By landforms, what I mean? By landforms, we have 4 main landforms, right? Mountains, plateaus, hills, and plains. So basically, by landform, I mean the feature on the Earth's surface. So when we superimpose these landforms and soil conditions, which are basically acting as modifiers to climate and length of growing period, modifier to climate and length of growing period, that means, let me put it very simply. For example, we know the landforms, for example, we are in mountainous regions or we are in plains. That kind of affects the climate over there. So everything is related. And hence, we are trying to superimpose these agroclimatic zone divisions with that of landforms and soil conditions and trying to draw agro-ecological regions. And therefore, within an agroclimatic region, there may be few or many agroecological regions depending on the soil condition. So hence, we have 15 agroclimatic zones as we talked over here, and we have around 20 agroecological regions that the country has been divided into. And for dividing these our country into these 20 regions, basically 4 important maps were used, or 4 important criteria were used, which is very important to know. Soil, physiography, length of growing period, and bioclimate. Don't worry, we'll see what are these in our subsequent slides. For the time being, just remember that 4 criteria, 4 important criteria, or 4 basic maps were used to delineate these 20 agroecological regions, and those were the soil type, the physiography of that region, the length of the growing period, and the bioclimate. Okay, let us move on to the next slide. Now, this is a confusion that many people carry and talk about. Look, when you Google it, you'll find in certain of the web pages, that it will talk about 15 agroclimatic zones that we recently discussed. In some other cases, some other web pages, you will see 126. Now, this is very confusing. See, the 15 agroclimatic zones, as I discussed, was delineated by the 7th Planning Commission. Whereas these 126 that you see, right, these 126 were drawn or delineated under a project, which is National Agriculture Research Project, which was carried out by ICAR. And the prime objective was to set up zonal branches for better regulation and administration of these zones. So basically, they kept on bifurcating these 15 zones until they reached these 126 zones. So for better administration and better regulation. But our prime focus is not over here, but we need to know about agroecological regions. So let's get rid of this one and talk about these broad 20 agroecological regions. And these agroecological regions were delineated by the National Bureau of Soil Survey and Land Use Planning in Nagpur, situated at Nagpur. So basically, they divided these 20 regions, and there was a reason why I discussed those 15 regions earlier, agroclimatic zones. So basically, these 15 agroclimatic zones were further divided into these 20 regions, but modified in terms of landforms and soil conditions. Now, what is the necessity? Why did we have to divide this 20? Why do we have to come up with these 20 regions? There were certain necessities or needs. So the first one is to assess the yield potentialities. For example, let us consider that a particular crop. For example, let us consider wheat. Suppose wheat is grown in Punjab. Suppose in a northern state. For example, wheat is versus suppose wheat is grown in a southern state, like in Telangana. So what are the yield differences? Even if we're growing wheat in these 2 conditions, there must be certain yield differences. And what are the factors that are actually leading to those differences is a prime objective as an agricultural scientist or people. So that was one of the reasons why there was a necessity to find out these yield potentials. And once we find out the yield potentials, then we can decide which crop is suitable for which region, right? So crop suitability or determining the crop suitability was the next target. And then once we find out or demarcate the crops for different regions or suitable for different regions, we can go for disseminating the agriculture research and technologies as required for different regions. For example, the technologies or the machineries that will be useful in say a plain land, for example, in Kharagpur, will not be or cannot be utilized in suppose a hilly region. For example, in Ooty, right? So to disseminate agriculture research and agrotechnology was also one of the needs or necessities. And the last one was to formulate future plan of action, right? We always formulate future plan of action. We set targets to achieve something after some years or something like that. So these were broad objectives by which this 20 different regions were delineated.
So Devas so I'm intervening for a second. So if you look at this, when you get that climatic zones alone,
Yes.
go back again, the agroclimatic zones alone wouldn't allow you to really assess yield potential, because you are only looking at climate and the length of the growing period in terms of for the agroclimatic region. So how much the crop is going to be yielding in a particular land unit or a region, that will not come from, that information will not come from climate alone and the length of growing period alone. And and so you need to have the soil quality, because the capability of the soil to supply that nutrients is a factor of also crop production. And basically in what sort of a land form, what kind of a crop you are going to select, that is going to also be controlled by the land form. Think about, for example, an upland crop versus a medium land or a lowland crop would be a lot more depending on what is the mean elevation, the location or position of a particular point above the mean sea level, for example. And so this landform soil, if you are to really look at the yield or crop suitability, or even you want to do develop some kind of a crop diversification plan, you need to have these. An agroclimatic zone alone will not really provide that information, although agroclimatic, both your climate and the length of the growing period is controlled by the climate anyway. These two are still the factor of yield and crop production. And so therefore that requirement is coming in, that not agroclimatic zone alone, let us really include that physiography and soils. Physiography is basically would allow you to delineate what is a lowland, medium land, kind of upland type, and soils would allow you to know what is the potential of that particular land in terms of supplying nutrients and in terms of hold the capability to hold water. These two are basically coming in from the soil type. Go ahead, Devasis.
Okay. As Sir rightly mentioned, and we'll also looking at one of the cases which will again explain what Sir told. But before moving on, into those ecological regions, we should have a kind of an idea what are those 20 agroecological regions are and where are they situated. So again, I'll give you a tour of this, and believe me, it is easy. Just follow me. Look, this map is something, I love this map. One of the papers that Sir must have shared with you has a map which is similar to this one, but this is something which I really love because it kind of makes easy to grasp the idea of these agroecological regions. Now, look here. See, if you ask me that what this India has been divided into, I'll say, see, look, there are not 20 regions, but there are broadly 5 regions. I'll tell you why. Because what I see is, I see a white color over here. I see a yellow region over here. I see shades of green over here. I see shades of purple over here. And I see shades of orange over here. That's what I see. I see these 5 typically different regions. And then these have been divided further. And if you follow this way, it will be very easy to understand all those 20 agroecological regions. Now, you may say, look, there is some kind of, I don't know, pardon me, but I'm very weak in colors. This is some pinkish kind of thing. But that also, represents a transition region. So I'm not focusing on that. So we have a very white region and a yellow region, and there's shades of green over here, shades of orange over here, and shades of purple over here. Now, let me take you through all these regions. So it is very similar to what we had seen in climatic zones, in the manner that we have the Western Himalayas over here and the Eastern Himalayas over here. If you remember, I just said it there, and I'm repeating over here. We have the Western Himalayas here and the Eastern Himalayas here. So you see a number 1 over there, right? That is Western Himalayas. Even this number 14 is also Western Himalayas or part of Western Himalayas, but they have been differentiated. As I said, a more, a more enhanced, or how shall I put it? Stress was given on soil conditions as well. So those have been again bifurcated. And there was a sentence in my first slide. Look, each climatic zone could be divided into one or more regions. And hence you see the example that they have been divided into more than one region. Okay. So this is our first ecological region, that is the Western Himalayas. Then we have a Deccan Plateau over here, which is 2. And in the south over here, we have 3, which is Deccan Plateau, right? Now you might ask, why 1 here, 2 over here, and 3 down south? Now there is a pattern. There is a reason why these have been numbered like this. Because I stated, and I'll give you a hint right over here, there were 4 broad criteria, right? There was physiography, there was soil, there was bioclimate, and as well as there was length of growing period. And based on those 4 criteria, this numbering has been carried out. For example, this 1 belongs to an arid region. Similarly, this 2 also belongs to an arid region. This 3 also is an arid region, my friend. So what we have here is these three places are arid. That is why the numbers 1, 2, and 3. But if you ask me what this region is, this is not an arid region. The easy answer is this is not an arid region, right? Okay, we'll see what region it is. If it is not arid, in the subsequent slides, just remind me what region it is, but it is not arid, right? And then we have this 1 over here, we have 2 over here, we have 3 over here. And then where do we have the 4th? The 4th is over here, the transition region. Why transition? You look, this is an arid region, and this one is a subhumid region. So when the transition takes place from arid to subhumid, whatever area is left out and within falls in that transition region. Basically, in a layman's perspective, what we are trying to do is we're trying to discretize something which is very continuous, and then even though this extreme will be very different from this extreme, but then the transition is smooth, and the properties which govern these transitions are also very smooth, which we'll see. So we have the 1 over here, the 2 over here, and the 3 over here, the Deccan Plateau. This is the 4th one, which is the northern plain and central highlands, including the Aravallis. This is the 5th region, which is the central Malwa highlands. Then you see the pattern: 5th, 6th, 7th, and 8th. 5th, 6th, 7th, and 8th, right? So this is 5th, which is the central Malwa highlands. Then we have, this is also coming under the Deccan Plateau, but this is a hot semi-arid ecoregion. I told you this is an arid region, and that is a semi-arid region, hence 2 different regions under agro-ecological divisions. And then the 7th one is this one, the Telangana Plateau. Then we have the Tamil Nadu uplands. So from 1 to 8, we have 1, which is the Western Himalayas. We have 2, which is the Western Plain Kutch area. We have 3, which is the Deccan Plateau. We have 4, the transition region, the Northern Plain and Central Highlands. The 5th one is Central Malwa Highlands. The 6th one is Deccan Plateau, but this is hot semi-arid ecoregion. Then we have the Telangana Plateau and the Tamil Nadu uplands. And then after 8, we again jump back over here, right? This is the 9th one. This is a subhumid region. Okay. So we have shades of green right now to deal with. We have 9th, 10, 11, 12, and 13. So we kind of form a circle over here. So 9, 10, 11, 12, 13. So the 9th is the northern plain hot subhumid ecoregion. Then the 10th one is also the central highlands, but this time the subhumid region. Then we have the eastern plateau, which is the Chhattisgarh plateau, which easy to remember. So we have Chhattisgarh plateau over here. We have Chhotan plateau over here, the 12th one. And then the 13th one is the eastern plain, right? So after talking about these green regions, which are nothing but broadly I'll put it like, look, these are subhumid regions. Then you can ask, look, what is this green? This is also a subhumid ecoregion, right? So this is the 14th one, which is the Western Himalayas. But because it is an arid region, this is a subhumid region, these have been divided, right? And then let us move to these purple regions over here. And when I say, look, these purple regions, there is also a criteria which has been used to divide these regions. And that is, these regions receive a very high rainfall. And that is why they fall into the per-humid regions. And I'll discuss what is this per-humid, humid, sub-humid. Don't worry about that. We'll see that in subsequent slides. But for the timing, remember there is a reason behind it. And that is per-humid. These regions are per-humid. They fall into the per-humid criteria, receiving very heavy rainfall. Okay, pardon me for my handwriting. So let's start. So we ended here in 14th. So we'll start here in 15th. The 15th one is Bengal and Assam plains. Moving on to the 16th, which is the Eastern Himalayas, as I stated earlier. Then we have these 17th, which are the sisters, not the 7 sisters, but the 5 one here, leaving the Assam and Arunachal Pradesh. We have all the 5 states which make up the Purvanchal or the northeastern hills, and we'll be discussing in detail over these parts. And then we are left out with these coastal regions, right? As I discussed in coastal zones. So we have these coastal regions. So this is my 18th and this is my 19th. So eastern coastal, western coastal, and then we are left out with the last one are the islands. So I think this might have given you some sense of how this entire country had been divided into 20 broad agroecological regions. And let me tell you, this has also further been divided into 60 agroecological sub-regions, which we are not going to discuss, but just remember. So these 20 agroecological regions, right, that I showed you has been divided into 60 agroecological sub-regions. This is directly taken from that paper that Sir must have shared it with you. And I'll give you one example. I'll just give you one example how these agroecological regions have been divided further into sub-ecological regions. Ecological sub-regions, sorry. So we discussed the first one is the Western Himalayas, right over here. So this Western Himalayas has been further subdivided into 2 agro-eco sub-regions. That is this one and this one. And then you would argue, look, there must be some reason behind that. And this is human nature. You know, we kind of keep dividing it back and forth. So Western Himalayas has been further divided into the eastern aspect of Ladakh Plateau and the western aspect of Ladakh Plateau and North Himalayas. And what you see over here is the nomenclature that is particularly used to demarcate a particular agroecological region. So what is this? This is the nomenclature. And this nomenclature that we'll be discussing in very detail in the subsequent slides. So let me keep it for the subsequent slide itself. See, this nomenclature is for agroecological regions, and this is for agroecological sub-regions. And this one is also for agroecological sub-region, right? So there is not too much of difference. What we see is when we keep on dividing into a number of branches, you know, so we kind of keep on adding suffixes. So what you see is the E has been changed into EH or the E has been changed into ET, you know. So this is the thing. Let us see in detail. So this table that I picked up from the paper, not the entire table, but what is necessary for us to understand is that, look, these agroecological regions are 20 in number, and there's that was divided for the resource planning at national level, and then these were again divided further into 60 agroecological sub-regions for resource planning at regional level. And the 4 criterias that we had talked about, soil, physiography, bioclimate, and LGP, have been mentioned here. And now the question is, what does these terms means, especially what is bioclimate and what is length of growing period? I've talked about these two, soil and physiography. What is bioclimate and what is LGP, length of growing period? Look, bioclimate is nothing but a zone which is defined in relation to the living organisms and the distribution. And by living organisms, what we mean is we are dealing with crops, like we are dealing with plants. So for us, it is crops. So we define or delineate this bioclimate based on crops or plants grown over there or suitable to be grown over there. What is length of growing period? Length of growing period refers to the number of days in a year during which the rainfall and the moisture that is stored in soil exceeds half of the potential evapotranspiration. Now, evapotranspiration is something I hope you all know. Now, this evapotranspiration is something like a demand, right? It's a demand. And the supply is rainfall or the precipitation. So the supply, if it is greater than the demand, then it is beneficial or it is favorable condition. If the supply is less than the demand, then it's unfavorable condition, isn't it? So broadly, I'm just trying to tell you, look, this length of growing period is nothing but it's kind of talking about the trade-off that we have between this demand and supply. In other words, it kind of tells you how many days in a year, how many days in a year the rainfall and the moisture that is stored in that soil is more than that is required by the plants, or is more than that evapotranspiration requirement. Right. Another term that we must know is degree of bioclimatic activity defined by FAO. It's nothing but, this is just the ratio of the precipitation to that of the evapotranspiration or the potential evapotranspiration. Right. Okay. Now let's talk about agroecological regions. As I told you, the nomenclature is used to demarcate each and every agroecological regions, right? So this nomenclature, believe me, is very easy. See, basically this consists of 4 letters. First one is an alphabet, followed up by a number, followed up by an alphabet, followed up by a number. So an alphabet, alphabet, and number. What we see over here, we have an alphabet, we have a number, we have an alphabet, we have a number, right? But you can argue, look, there is 2 alphabets over there, but that's not an agroecological region, that's an agroecological subregion, right? So that's a suffix that has been used over there. So let me, for example, take A13E1, right? A13E1. Now, this A13E1, as we had seen earlier, like this represents the Western Himalayas, the first region, the first agroecological region, right? Now, out of these 4 letters that are being used to, used in nomenclature, these 4 things represent these 4 criteria that has been used. The first one represents the physiographical region, right? The first one represents the physiographical region. The second one, the number, represents the soil type, right? The third one represents the bioclimate, and the fourth one, the number, represents the length of growing period. So I think it is clear till now how the nomenclature has been carried out. So there's nothing so difficult in understanding. Look, this A represents the physiographical region, which is the Western Himalayas. Then 13 represents the soil scape or the soil type, which represents shallow skeletal soil, the soil which is predominant in that area. The E represents basically arid region. We'll see that represents arid climate, right? Arid bioclimatic zone. And H, which is the suffix which has been used here, represents hyper. And then we have 1, which is the last one, representing the length of growing period. So hence, what I want you guys to take away from this particular slide is, look, this nomenclature consists of these 4 letters. One is alphabet, then a number, then an alphabet, then followed by a number, right? And what these particular alphabets or numbers represent. And length of growing period, my friends, length of growing period kind of tells us a story. What the story is, look, if the length of growing period is less than 90 days, that means that particular region is feasible for growing a single short duration crop. Now let us go a bit deeper into this. Now I told you when I'm discussing this, the definition of length of growing period, that we can fairly argue that length of growing period kind of gives us an idea about the number of days there is a rainfall, or most of the rainfall occurs in these days. So if it is less than 90, that means throughout a year, out of 365 days, there are 90 days in which most of the rainfall occurs. And if most of the rainfall occurs within those little span of time, we cannot go for 2 crops. We cannot go for 3 crops, right? We cannot go for relay cropping. So it is only suitable for 1 crop a year, for a short duration crop. If LGP is 90 to 150 days, then we can go for 1 medium duration crop or a 1 short duration crop followed up by a relay crop, right? And then if it is greater than 210 days, for example, over the year, more than 200 days, you have the demand, the supply side is more than the demand, then you can go for 2 crops at least for double cropping. So that's what the LGP tells you. Okay, now these are the tools that are used for agro-ecological regions nomenclature. We talked about the physiographic regions, right? We talked about soil classifications, we talked about bioclimatic conditions, and we talked about length of growing period. And these are those 4 letters that I'm repeatedly telling you because this is very important to know. So this is the first alphabet, right? So the alphabet you see over here, or the letters, that basically demarcate different regions or the physiographic regions. For example, A, we discussed, right? A13E1. So A basically represents Western Himalayas. Similarly, C represents Eastern Himalayas. D represents Northeastern Himalayas, and so on and so forth, right? The second one was a number. So it was, I guess, 13. So the 13 represents the soil type. So the numbers, different numbers represent different types, and we are stuck over here, the 13, which represented shallow skeletal soils, and that must be clear, right? So similarly, 1 would represent red loamy soils. Wherever we see 1, that would indicate red loamy soils, 2 for red and lateritic soils, 3 for red and yellow soils, and so on and so forth. Third was again a letter, and we had E over here, isn't it? So E basically represent an arid region. So similarly, our entire country has been divided into 5 broad bioclimatic conditions. And I want you guys to remember these 5 at least, because this will give you an idea, and we'll see how we can actually figure out what the nomenclature should be, right, of a particular region. So we have the entire nation divided into these broad 5 bioclimatic regions. We have A, we have B, C, D, and E, representing perhumid, humid, subhumid, semi-arid, arid. Now, again, I'm just going back again to that layman's perspective because I find it very easy to relate to these ideas. You see, what is humidity? Humidity is nothing but a measure of amount of water vapor in the atmosphere, right? It could be on, say, mass per mass basis or volume per volume basis, but we are not concerned with units. Let us stick to the concept. So if the region is arid, that means, the water vapor is very less in the atmosphere, not good enough. If it is perhumid, oh, that is excess. That is really excess, right? So that's the motive behind this division. We have perhumid, humid, subhumid, semi-arid, and arid. So we are going to the scantier and scantier regions in terms of humidity. So that E represented arid region, isn't it? And then we have the last one, which was, I guess, 1. That represents the length of growing period, which was less than 90 days. Right? That means whatever rainfall that we're receiving, I am talking in general sense, whatever rainfall, or more particularly the water content in the soil, is for the period of 90 days or less, more than the demand by the evapotranspiration. So in those period, we can go for a crop or maybe a 1 crop, short duration crop. That's what it tells us. So these are the tools which are used for agroecological regioning nomenclature. Now again, I've stated this 20 agroecological regions, but this time I've stated the way it is being written in scientific papers. You'll find also the paper that was shared by you, by sir. So what we find is, look, I told you this is Western Himalayas. So first region is Western Himalayas. But then it's followed by comma and the ecoregion that it belongs to. So it states clearly that it's cold, arid ecoregion. And if you dwell around in that paper that has been shared, you'll find this. So it's written cold, arid ecoregion and followed by the nomenclature within the parentheses. So I think the slides that we have discussed so far have made you reach that level that you can understand and not, get scared of what is written. So here we have Western Himalayas followed up by the ecoregion that it belongs. It's a cold arid ecoregion, and the nomenclature it follows A13E1, right? Similarly for different regions. Okay, let us focus on the map that I've provided here. See, it is very easy for us if we go back to our elementary school level and think about the soil types that we had discussed. And this is particularly a map that I've taken from geography chapter, which is basically taught in CBSE classes. If you are from CBSE, well, this is very easy for you. This you must have seen. This is basically, it talks about different soil types, and in elementary schools we have discussed like this is the mountain soil, this is the desert soil, this is fertile soil, that is alluvial soil. Then we have a predominant black soils over here. We have red and yellow soils here with the patches of lateritic soils here and there. So this basically gives us an idea. Look, this is, now keep a keen eye on this. Now this is the soil type that has been divided, and I'm choosing this for a region. Now this is very easy to even capture. So this is the broad soil types. Now look at another map that I have also picked up from geography book of 9th standard, right? So this talks about the rainfall patterns. What amount of rainfall that do we receive in different parts of India? And I'm telling you all this because of a region that we'll see. We have very high rainfall over here, which you can see about 400 and so on and so forth. We have a little bit less here, and then even more scantier and yeah, very less over here. So that's the broader idea that I want you guys to have in your mind, because we'll be predicting a lot of things. Now this is a particular map. This is not from geography book, but this is the concept that has broadly been used. And this is the concept provided by Thornquist. This is the concept of water balance. Now, this entire region, the entire country, was divided on the basis of the concept of water balance. What did Thornquist say? Thornquist said, look, based on the concept of water balance, if a particular place is receiving rainfall more than it is required, then it is having a surplus. If it is receiving rainfall that is less than what is required, then it falls in the region of water deficit. And hence the entire country was divided into regions which are receiving very high rainfall, like which were called as per humid regions, receiving very heavy rainfall, and those receiving very less rainfall, arid, and all others coming in between, right? And hence, yeah, this was provided by Thornquist, and then subsequently it has been gone under minor modifications. So don't worry about that. We'll see. But I want you to pay some attention where the subhumid regions are, right? These are these regions. And if you remember, those were the shades of green, green, not green. Okay. So that's where the shades of green that green again. I'm so sorry. Green that we see, right? And then we see the arid region over here as well. So yeah, let's move on to the next slide. And I'm in love with this map, and this is where the real game happens. I'll tell you, you'll be able to predict what the nomenclature is once I give you one example. And I'll start with the example that we have been talking about. This is the Western Himalayas. And the Western Himalayas, and this nomenclature, cold arid ecoregion A13E1. Now, what does E represent? E represent an arid region, because they are basically receiving very low rainfall, right? What does 1 represent? Less than 90 days. The LGP is less than 90 days. Right? And somehow you'll see this pattern evolving throughout all the agroecological regions, that you see this E basically associated either with 1 mostly or with 2. In other words, a region which is receiving less rainfall is prone to be arid, and also the soil water content is, if it is not influenced by some other factors which we'll see, is supposed to have less LGP less, right? So that means the soil water content will be in excess for less than 90 days, because it's receiving the majority of rainfall in that shorter duration, right? So let's have a tour of this country, but not all the regions, but only 5 regions that I picked up, which differ dramatically, but it will give you a sense of what other regions should be. This is the second region that I'm picking up, and for a region, of course. Look, this region is the Western Plain, Kutch, and part of Kathiawar Peninsula, and this is a hot and arid ecoregion. And here you see EN1. Here you saw EN1. Here also you are seeing EN1. That basically represents arid and less than 90 days, right? Length of growing period. But I'm picking up this Tamil Nadu uplands now. Now, can you really guess what its nomenclature should be? Or let me help you a bit. Now, I know this is the Tamil Nadu uplands. I know This is the region of Tamil Nadu uplands, and this is a hot semi-arid ecoregion. If you remember, I talked about this is a semi-arid ecoregion. Only this patch of land, kind of is an arid ecoregion, and if you are good in geography, you get to know why that particular place, that small spot over there, becomes arid, and everything around it is semi-arid. Right? It has to do with the Eastern Ghats. There's a reason behind that. So, okay. So, can you guess what this should be? Right? What does D represent? D represents semi-arid, right? And what do you think this should be? Right? I'll tell you. This is mostly, if my guess would be, it should be 2, right? It should be 2. LGP is 90 to 150. As I said, this is kind of a reciprocal relationship. If it is E, you will see more of 1 and 2. And I'm not joking. If it is A, you will see more of 5 and 4. Right? So it's kind of reciprocal, where E is associated with 1, A is associated with 5, subhumid C is associated with 3, and so on and so forth. Right? So this is basically H1D2. H1D2. What about this? This is a region which is receiving very heavy rainfall, right, per humid region. Thornwood said, look, this is having more of supply than that of demand. This is northeastern hills, right? This is the 17th ecoregion. And can you guess what it should be over here?
A5.
A.
Yeah,
A.
correct. So it would be A, right? It's a per humid region. That's a very good guess. You people are genius. Now let's move on to the next one. The next one is the Chhotan Plateau, and this I picked up for 2 reasons. I'm biased because it covers most of Orissa, and as well as here you see a typical nomenclature where you see a parenthesis within another parenthesis. So it basically says, look, there is J2C 3 followed up by parenthesis and a 4. That what does that say? It says, look, 3 says, look, this LGP is 150 to 180 days, but this region also consists of some particular pockets which are having an LGP of 180 to 210 days. Let me clean that up. Isn't it? So I think this is clear. And whenever you see, whenever you read that paper, you go through that paper, you'll see a number of ecoregions which have been has a nomenclature something like this. So a parenthesis within another parenthesis. That means that you see we are basically trying to discretize something which is continuous, and we keep doing that in every sector. This is human nature. So you'll see that there is parenthesis within parenthesis, and then we have some suffixes, then prefixes, and so on and so forth. So let's get going. Let's talk about these 5 broad different agroecological regions, and then you can make out other regions as well. Okay, here we are to my last slide, and I'm going to discuss only these 5 regions and leave you the rest with the rest. So we'll start it with this Western Himalayan coal ecoregion, which is having a nomenclature of A13E1, isn't it? So we have 4 letters. Okay, so an alphabet followed by a number, followed by an alphabet, and again followed by a number, right? So the first alphabet represents the physiography. Second represents soil. The third represents anyone? It represents bioclimate. Let me tell you. The last one, yeah, bioclimate, and the last one is the length of growing period. Okay, so this covers the area of Ladakh and Gilgit districts. Wow, great thing. And this has a agroclimate, as you can make out, because it's in the Western Himalayas, yeah, top over there. So they do not have, very hot region. So they have just a mild summer and severe winter. But we are here to discuss science from the science perspective, right? So they are receiving a rainfall, very less rainfall, less than 150 mm, mostly frozen by ice, and then having an LGP of less than 90 days. And that should not be a very scary thing, because I told you 1 represents less than 90 days. They are having shallow skeletal soils, mostly calcareous soils. And why shallow? And I searched it. Shallow means the depth of soil is very less. And here the division has been as such that if the depth is less than 50 centimeter, the soil depth, I'm talking about the soil depth, if the soil depth is less than 50 centimeter, they have named it shallow. If it's less than, or it's in the range of 50 to 100 centimeter, then it's medium. And if it's greater than 100 centimeter of depth, then that's deeper, a high depth, whatever. Yeah. So it's a shallow skeletal soils. Yeah, and we can make out because yeah, see, we are talking about mountain tops and very new, right? And then what is the land use there? Of course, we are not going rice there. The net sown area is very less because it's mostly covered by snow. So the net sown area will be less, and it is 2.5%. And the major part, whatever they grow, is under vegetables, or you'll somewhat see wheat and fodder, and in that order. So you mostly see vegetables, and then followed up by wheat, and then fodder. And as we know, Kashmiri apples, very famous, right, worldwide. So the major fruit is Kashmiri apples. But what are the constraints? What do you think will be the constraints? Severe climatic conditions? Yes. They have craic temperature regime, which I think you will be studying about temperature regimes, or you must have studied. Craic temperature regimes basically represents, the soil temperature to be less than 8 degrees Celsius and greater than 0 degrees Celsius. And then they have a narrow crop growing period. Okay, that's what the LGP represents. Less than 90 days, so the crop growing period is very less. So they go for one crop, not two crops, isn't it? And they have a very high calcareous nature of soils. Then we'll move on to the Rajasthan area, right? So the Western Plain, Kutch, part of Kathiawar Peninsula, which is a hot, arid ecoregion, is also an arid ecoregion, and that's why we see E1. We saw E1 over here, then we see E1 over here. That kind of tells us a story, right? But M represents that Western Plain, so don't get too much worried about that. Now it covers parts of Punjab, Haryana, mostly Rajasthan, some parts of Gujarat, and Kutch Peninsula, and so on and so forth. And it is having a very hot summer. It's a mild summer. Now we have a very hot summer, but still arid. So you see, these all factors are related, but then there are certain differences, which these landforms and these soils and this, LGP and this bioclimate play, right? And they have a very cool winter, and hence it also makes them arid. And they receive a rainfall of what? They receive a rainfall of less than 400 mm. And can you guys just guess me? I think you people would have guessed already. The question mark asks you what LGP it would be. What LGP it should be? What?
90 to 150 days.
Not exactly. Yeah, less than 90 days.
Less
Because,
than 90 days.
yeah, less than 90 days because one is less than 90 days, isn't it? If you don't remember here, you see one is less than 90 days, two is 90 to 150. Subsequently, we are increasing 150 to 180, 180 to 210, greater than 210. Okay, so that basically here represents less than 90 days. Yes?
Sorry, I didn't see the number 1 written after E. I just noticed 400 mm and I thought it was so much more than 50 mm in the first case.
Okay, it's okay. So yeah. Let's talk about soil types. I showed you that soil map, and we know that we have desert soil, and desert soil, sandy soils often face this salinity problem, and hence desert and saline soils. And if you have not read it, you will read it. Don't worry. But if it is receiving less rainfall of 400 mm and so, and it is having an LGP say 90 days, right? Less than 90 days, somewhere around 60 days even. So do you think they should go for 2 crops, or do you think they should go for 1 crop? If provided irrigation is not available, mostly they should go for 1 crop, monocropping. So mostly you will see rain-fed monocropping is their predominant agricultural land use practice there. And resistant and short duration rainy season crops are grown. For example, pearl millet, which has, having a water requirement of even less than what shall I put it? Less than 20 centimeter, 200 millimeters. So pearl millet has a very less water requirement. So they go pearl millet predominantly over there, and also fodder and some pulses. You do not go for rice over there. Rice has a water requirement of around 120 centimeter or 1200 mm. In the range of 1200 to 1300 mm, and you are not supposed to grow, or this thing does not allow you to grow. So we are kind of looking at the science behind the geography, right? But if irrigation is available, will you go for rice? I'll say no. We cannot go for rice because you see these are desert soils and they do not hold water. And one of the things that is required for rice is the soil to hold water, right? And then what other things, if water is available, what other things can we go for? They go for cotton and sugarcane, right? And hence, what are the constants then? They have erratic and scanty rainfall, soil salinity is predominant, and acute droughtiness. That means drought. There's something that I saw in the paper. And nutrient imbalance, right? You'll look into that later on. Okay. So let's now move on to the eastern side of our country, right? Northeastern hills, the Purvanchal region, that warm per humid ecoregion. Per humid. I mean, reiterating that same thing again and again, that goes into your mind, because you see now this 1 has changed into 5, or the E1 has changed into A5. And I told you that kind of goes with the story. A is more related to 5, A is more related to 4. And you'll not see A1, you'll not see A2 in nomenclature, but you will see A5. On the other hand, you will see E1 or E2, you will not see E5, right? So these cover these regions of Nagaland, Meghalaya, Manipur, Mizoram, or all those parts, right? And you'll see the climate is more so like a warm summer and a very cool winter. And these people kind of, you know, the Indradev is very happy with them. They receive 2,000 to 3,000 mm of rainfall throughout the year. They keep receiving, and you see the LGP is greater than 270 days over there, more than 270 days in that Purvanchal region. That means throughout the year, in a 365 days, out of 365 days, 270 days they have LGP higher. So they have supply side more than the demand, right? And if you just kind of have a hint or remember the soil types, they are predominant red and lateritic soils, the patches of lateritic soils over there, right? So they have red and lateritic soils. And yes, I just wanted to mention this jhum cultivation. You must have heard in your elementary school level. So jhum cultivation you see predominantly on the eastern northeast side. So they used to, although nowadays this is demotivated not to go for jhum cultivation because of the disadvantages associated with it. But they still go for jhum cultivation, and they go for millets, maize, potatoes at higher altitudes. So if they are growing at higher altitudes, they prefer to go for millets, potatoes, and this also has a reason behind that. And in valleys, they grow rice in June, and the reason is, you see, if you know how the water profile works in the valleys, kind of the water profile gets accumulated, to the surface. So they, in a layman perspective, let me again put it the layman perspective here. You see, the valley has a water profile which kind of, for example, this is a valley, right? So if you irrigate this and the water profile is something like this, so this kind of gets accumulated over there, and this is favorable for growing rice because it's holding water. But if you go to higher altitudes, the water profile is different. The water kind of percolates down at a faster rate, and then it's not suitable to grow rice, right? There are exceptions. You can talk about terrace and all that, but let's, for the time being, just focus on this. And then we see excessive rainfall leading to leaching, deforestation, and shifting cultivation, result in severe soil erosion hazard. And that's why this is one of the reasons that jhum cultivation is being demotivated, not to go for, right? Let's come to the eastern plateau, the Chhotan plateau and the eastern Ghats, covering most of that Odisha. And it has J2, C3, and within bracket book 4, we'll see what is that. And it covers parts of Bihar, West Bengal, Odisha, Bastar region of Chhattisgarh. And we have hot summers and cool winters here. We have hot summers. It's a very humid region, subhumid region, not humid. So, and it receives a rainfall of 1,000 to 1,600 mm. And if you're good at geography, or you were good at geography, you kind of, then put that image of that monsoon, which hits at Kerala and then bifurcates from that and goes, one part goes to the eastern side and the part goes to the western side. We'll talk about the eastern side. The eastern side reaches the northeastern hills. It hits there, we have heavy rainfall, then retraces back. And when it retraces back, it comes over this region, and then we see that the rainfall kind of goes on decreasing thereon. So we see 1,000 to 1,600 mm here, whereas we see 2,000 to 3,000 mm over there. And the LGP, should be less than this, but it should be more than that. So it's somewhere 150 to 180 days. So mostly it is 150 to 180 days, but there are patches of land where you'll see 182, 200 days, and hence the 3 within parenthesis 4. So 3 is predominant. Within parenthesis, there are patches which has an LGP of 180 to 210 days. Okay, now that question mark is, what type of soil do you think should be there? Or is
lateritic soil.
Yeah.
Right.
Yeah.
Lateritic soil.
And I think, and how did you get to know that?
Sir,
How
upper
did
one
you
is
guys?
red.
Second number is 2, sir. Yeah, bow number is already
Correct. Whoever said that 2 represents red and lateritic soils, yes, the 2 over here represented red and lateritic soils. The so it's red and lateritic soils.
Your presentation
Great.
is gone, sir.
Yes.
I think it's showing.
Let me complete. I'm almost there. We have rain-fed farming over here. Okay. We have rain-fed farming over here. We grow rice, we grow pulses, we grow groundnut. In the Kharif season and in Rabi, we go wheat. And if irrigation is available, sometimes farmers also go for rice. And we face seasonal droughtiness, not like what is seen in Rajasthan, but seasonally, if there is no rainfall, for example, suppose a year, I think not the last year, but last year had a severe drought in this part of the world. And we have subsoil graveliness. And what does this graveliness mean? You see, if the soil is coarse, if you know about soil texture, if the soil is coarse, it will, so that means it has more of sand or maybe gravel, so it will be unable to hold water. The water is going to get percolated, right, more easily. If it has more of clay, if it has a fine soil texture, it will hold more water. And because this area has coarse soil, because this area has a coarse soil texture, the water kind of percolates down, and hence we see this low available water capacity in this region. And wherever you will see there is a coarse soil texture, you can fairly argue that that particular region should be having low available water capacity. That also means, take a step further, we need more frequent irrigation in those areas if we have one. And then we also see that these regions of red and lateritic soils kind of suffer from phosphorus fixation, right? And let's come to the last one, that is the Tamil Nadu uplands, just down bottom of our country. And this has eastern Ghats, southern parts of Deccan Plateau, Tamil Nadu uplands, and western parts of Karnataka. So some parts of Karnataka are also covered here. This is a very hot and dry summer. These areas have hot and dry summer and mild winter. So the winter is not that severe. And this have a rainfall of 600, 1000 mm. Again, I'll tell you that retracing of monsoon, right? It retraces back, if you kind of imagine, and that the amount of rainfall kind of goes on decreasing. So here you see a decrease, right? 2000 to 1000, 1600, and then we again go back a little bit further, 600 to 1000 mm, and everything has a concept behind it. And the LGP, because it represents 2 year, right? That falls in the area of 90 to 150 days. Someone told me 90 to 150 days earlier, right? So the 2 here represents 90 to 150 days. And these have red and loamy soils, right? So the 1 over here represents red and loamy soils. And most of the times you'll see these people or these areas, you'll see predominantly having millets, pulses, groundnut being grown in the Kharif season, sorghum, safflower in Rabi season. You can also go for rice, cotton, sugarcane if irrigation is available. And then what are the constraints that these areas face? One, they have high runoff. They also suffer from coarse soil texture. And if they suffer from coarse soil texture, I think now you are in a stage to argue, look, these soils have low available water capacity. And that kind of leads to severe droughtiness. And now you can argue, look, severe droughtiness, why here severe droughtiness and not the above one? Because you see, droughtiness is something, a function of not only the soil type, but also the bioclimate. So if it's an arid region or a semi-arid region, then it kind of drags it into a severe droughtiness criteria. And then, yeah, that's it. I think I have completed what I wanted to say. So thank you.